Next is properties of charges, that is we already know. Same charge, like charges, they will like charges repel each other, and unlike charges they will attract each other. I think it's a self-explanatory property. Clear? Now, second property. Okay, so this is an example of you can see repulsion. If there is a repulsion, so force on this will be in opposite direction, like this. You can see here. Okay, neutral, there will be no force, and yeah, if two unlike charges are there, then they will attract each other. Okay, it's a, I think we already know about this property. Second property. Okay, so these are the fundamental properties of charge. Second property is charge is conserved. Means we can't create charge, we can't destroy charge. Okay, so charge is neither created nor destroyed, but we can transfer. We can transfer charge from one body to another body. Okay, so let me give an example. So you can see here. Okay, so before, so there is same number of you can say negative and positive charges. Okay, now let's suppose there is a rod of charge positive 4e. Okay, it means, what does it mean? It means it has lost its electrons. Now there will be tendency of attracting electrons from other bodies. So when we will touch this rod with this sphere, okay, so it will acquire a couple of electrons. Let's suppose it has acquired 2 electrons. So now we can see charge of this rod, it will be plus 2e. It means it has gained electrons. It has gained electrons, and it has lost electrons. Clear? But as a system, you can see total charge is conserved. Why? Because initial charge, it was how much? Plus 4e, this one plus this, plus 0. So initial charge, it was plus 4e. Clear? Now final charge, this one, you can see it's plus 2e plus again 2. Answer will be plus. So you can see as a system, the entire charge of this system, it's conserved. But two electrons, we have transferred from one body to another body. Clear? Now let's move forward. Is there any doubt, any confusion so far? Okay. Yeah. So next couple of properties we have already discussed. Yeah. So next property. So basically, it's right now we don't cover this property, but yeah, for the sake of noting down, you can note down this: mass of a particle varies with its speed. Okay, when the speed of the particle is comparable with speed of light. Speed of light. So there is a formula. Okay, so mass is equal to initial mass, that is m0 divided by 100 of 1 minus v square divided by c square. In case speed of particle is how much? It's tending to speed of light, that is 3 into 10 to the power 8. At that moment, mass of a particle, it will vary with speed. Okay, but the speed, it's very, very high speed. Okay, but charge, it's independent of speed. Okay, so the amount of charge that is at rest, it will be its value, its amount, or we can say its magnitude, it will be same whether it's moving with speed of light. But mass of particle, it varies with speed actually. Clear? You can note down. Okay, so now next property, I think we have covered already, that is charge is quantized. Okay, so charge on a body must always exist as an integral multiple of fundamental unit of charge, that is E. So we have already discussed that is, so total charge on any object or on any body, it will be n times E, where n is integer. It's positive integer. Okay, so charge, it can't exist like this, plus 2.5 E, plus 1.5 E, 3.79 E. So charge, it can't exist like this. Clear? And it's a very, very important property of charge, that is charge is quantized. Okay. Yeah. So let's try a couple of questions based on this concept. First is minimum magnitude of charge, that is quantum of charge an object can have if measured in. I think most of you can give answer this question in the snap. Why? Because minimum magnitude of charge is how much? Charge of electron, that is 1.6 into 10 to the minus coulomb. So it's the most easiest question. Clear? Okay. So now let's compare properties of charge versus mass. Okay. So first property, electric charge, it can be positive, negative, but mass will be either it will be 0 or it will always be positive. For example, if there is no mass, then mass is 0, but it can't be negative. Secondly, charge is conserved, but mass is not conserved. I think most of you remember there's a very famous equation given by Einstein, that is E is equal to mc square. So we can convert mass into energy also. Okay, but charge is conserved. Third, charge is quantized, but there is no quantization of mass. Fourth, charge is relativistically invariant. Means charge, if it is at rest or either it's in motion, so its value, its magnitude, it will be fixed. But mass is variable. It varies with speed. Clear? Fifth property, force between charges, it can be negative also, so it can be attractive also, repulsive also. But in case of force between masses, it is always attractive. Okay, I think most of you remember formula, force between masses, that is gravitational force. It's given by capital G. Wait, let me. M1, M2 divided by d square, where d is the distance between two masses, where M1 and M2 are the masses. Clear? You can note down these points. Okay, so next, yeah, let's try one question. Question is, which of the following properties statement, sorry, which of the following statement regarding electrostatics is wrong? Option A, B, C, and D. So first is charge is quantized. B, charge is conserved. C, there is an electric field near an isolated charge at rest. Option D is stationary charge produces both electric and magnetic fields. No, it's not. So the answer is D. Okay, the answer is D. Okay. Yeah. So now, so far we discussed about that any object, if it has lost some electrons, then it will carry positive charge. If any object is having extra electrons, then it will have negative charge. But what are the methods by which we can transfer charge from one body to another? Clear? Okay. So let me give an example. So basically, you can see. So if you talk about electron, so basically it's a Greek word electron, meaning amber. So amber rubbed with wool or silk cloth attracts light objects. Why? Because when we will rub two objects, there will be transfer of electrons from one object to another object. So because of that thing, because of that process, so both will carry positive charge and negative charge. For example, amber, it's neutral. Initially, it's neutral and it's also neutral. Okay. So now when we will rub, so you can see it has acquired extra electrons. So now it's carrying negative charge and it's carrying positive charge. Clear? Okay. Yeah. So now let's discuss couple of methods. Okay. So by which we can transfer charge from one body to another. Okay. So first method is friction, charging by friction. Charging by friction. Okay. So basically, the name of this method is self-explanatory. Charging by friction means we have to rub two objects with each other. Okay, we have to rub two objects with each other. Okay, and again there will be transfer of electrons from one body to another. Clear? Now let's suppose you can see it's it's neutral. Again it's neutral. So now we are rubbing each other. Okay. Now let's suppose you can see towards this object it's negative electrons, or we can say negative charge, these are aligned. So we can say now it's carrying negative charge and it's carrying positive charge. Clear? Okay. So first method is charging by friction. So basically in this method, we need to rub. So basically there must be a physical contact between two bodies. Only then we can transfer charge from one object to another. Okay, but there is properties. The net charge, total charge of the system is conserved. We already discussed about this property. So basically we are transferring charge. We are transferring charge from one object to another object. But we are not creating charge, we are not destroying charge. Okay. So basically, yeah. So when we are rubbing two objects, okay. So one object is having less affinity. Less affinity means it can lose its electrons. Okay. So it will become positive. And second, next object, it's having more affinity, or we can say greater affinity towards electrons. So it will attract electrons, lose electrons from next object. So it will carry negative. So basically, it's having deficiency of electrons and it's having excess of electrons. Excess of electrons. Clear? But the entire charge on the entire system, it will be conserved. Clear? So let me give one example. So basically you can see, yeah. So one is neutral reg and second is neutral PVC pipe. Okay. So now when we will rub neutral reg with PVC pipe, so one of them, it will lose its electrons, and second, it will gain extra electrons. Okay. Yeah. Second is silk and glass. Silk and glass. So when we will rub silk with glass, okay. So now glass, it has less affinity towards electrons. So glass, yeah, lost electrons, and silk cloth gained electrons. But the total charge of the entire system, it will be constant. It will be constant. Clear? Okay. So glass, it's having less affinity towards electrons, but silk, it's having more greater affinity towards electrons. So that's why it will attract loose electrons from glass. So that's why the polarity of silk cloth is positive. Sorry, negative. Clear? Is there any doubt, any confusion so far? Okay, so let me give one example. Yeah, now, so there is a rubber rod and fur. Rubber rod and fur. Okay, so now, yeah, so basically we are rubbing rubber rod with fur. So glass, it's having less affinity towards electron, so it will lose electrons, it will gain electrons. So after rubbing silk cloth, or we can say fur, fur or cloth, it will have negative charge, and glass rod, it will have positive charge. Okay, so if you're talking about rubber rod plus fur, so this time fur lost electrons and rubber rod gained electrons. Okay, but in case of cloth, so this time so it will lose electrons, and cloth, it will gain electrons. Any doubt, any confusion? Clear? So you can note down. So basically, you have to remember all these examples. So there is no, we can say there is no concept behind this. So basically, you have to remember. So which will lose or gain electrons. Okay. Now let's try a couple of questions. Yeah. So question is, if a glass rod is rubbed with silk, it acquires positive charge because option A, option B, option C, and option. Let's try this question. So the statement of this question is self-explanatory. Why? Because if a glass rod is rubbed with silk, it acquires positive charge. It means electrons are removed from it. Answer is B. Answer is D. Okay. Yeah. So it's a very basic table. So you can note down this. So positive charge, negative charge. So glass rod, If we are rubbing glass rod and silk cloth, so silk it will carry negative charge. Okay. Now second point, when we are rubbing fur with rubber or ebonite rod, so rubber or ebonite rod, it will carry negative charge. Third, woolen cloth, umber or plastic object. Umber, plastic object, they will carry negative charge. Dry hair and comb. So comb, it will carry negative charge. Dry hair, they will carry positive charge. So it's a very basic table you can note down. Okay, so this is the first method. It's a first method. Basically, charging by friction. So we have to rub two objects with each other. Here. Now, let's move towards next topic. That is, charging by conduction. Charging by conduction. So what does it mean, conduction? So in friction, there is rubbing between two objects. But in conduction, electrons, they will transfer from one object to another object. Clear? Okay. But the condition is finally both objects will have same charge. Same charge. Okay. Because of charge difference, so extra, or we can say extra electrons, they will move towards deficient object. But after some time, the polarity and the amount of charge, it will be same on both objects. After that, transfer of electrons from that one object to another object, it will be stopped. Again, in conduction, so there will be you can say there will be physical touch between two objects, but this time charge will be same. Okay, so charging or conduction, so it will require only contact between two objects. There is no rubbing. There will be no rubbing, will not be required for conduction. Okay, but finally, both are carrying same sign and equal charge on both the objects. Clear? So we can say the total charge is distributed between the objects. Clear? So basically, so the point, this point, equal charge. So basically, it's not important that every time charge will be same, but the polarity of charge, it will be same. Same sign. Clear? So for conduction, again, there is physical, we can say there is a contact required between two objects. Clear? Any doubt, any confusion? So finally, in case of charging by conduction, both the objects, they will have same polarity, same sign, same sign. Clear? Any doubt, any confusion? Now, third method is charging by induction. Charging by induction. So basically, in induction, so there will be no physical contact. There will be no physical contact. Okay. So basically, what will happen in induction? So electrons inside conductor move to create surface charge. For example, there is a negative charge rod. Okay. Now if we take this negative charged rod towards this, we can say neutral. Initially, it's neutral sphere. Okay. So there will be repulsion between electrons of this negatively charged rod and electrons which are present inside the sphere. So because of repulsion, so on the right hand side, there will be negative polarity. Okay, so basically electrons, most of the electrons, they will move on the opposite phase. Why? Because of repulsion. Because of repulsion. So we can say on the left hand side there will be positive polarity, and on the right hand side there will be negative polarity on the sphere. But we can see there is no physical touch. But the charge on this sphere remains conserved until unless there is no earthing. So for earthing, we will talk about later about earthing. Clear? Any doubt, any confusion? Okay, so let me give one more example about induction. Yeah. So what is induction? So induction, it's a process. Induction is a process in which a charged body can be used to create other charged bodies without touching them or losing its own charge. So now again I'm repeating same point, that when we will take this negatively charged rod towards this, okay, so finally we can say there is, I'm writing here, yeah, negative side. Okay, negative phase, it's negative side, it's positive side. Okay, but charge on this negatively charged rod and charge on this sphere, both are conserved. Both are conserved. Until unless there is no earthing used. Until unless there is no earthing used. Clear? Okay, so let's try a couple of questions based on this concept. So question is, a neutral metallic sphere is placed near a negative point charge outside the sphere. The net charge on the sphere then. Option A, option B, option C, and option D. Let's try this question. Okay, so let me solve this question. So question is, a neutral metallic sphere, it's neutral. Okay, is placed near a negative point charge outside the sphere. The net charge on the sphere, there is no physical touch. There is no rubbing between both the charged particles, charged objects. Okay, if this is the case, then we can say this is the case of induction. So answer will be 0, neutral. Why? Because there is no rubbing between both the charges. There is no physical contact between both the charges. So charge can be induced. We can say the charge here, it's a negative charge. So because of this negative charge, this side it will be negative and it will be positive. But the total charge on the sphere, it will be 0. It will be 0. Clear? Okay. So let me give another example of induction actually. So we can say yeah. Now, okay. So there are two objects, A and B. Okay. So initially they are in contact. They are in contact. Now, in second stage, it's the first stage. In second stage, okay. So now, we have placed a positively charged rod near this system or near this combination. So now, negative charge or negative electrons, they will be attracted towards this. So we can say it's a negative side and it's a positive side. Okay. So now we have removed the physical contact. Okay, the physical contact. So now the when we have removed the physical contact, or we can say we have placed them instantly. We have separated them. Okay. So now you can see on this side, or we can say on object A, there will be negative charge, and on object B, there will be positive charge. So now they will attract each other. Okay. In case, again, we have placed this positively charged rod. Again, all the electrons, they will be attracted towards this one. So by using this, we have created positive and negative charge. But the entire charge of the system, what was the initial system? This combination. Again, net charge is 0. Net charge is 0. Clear? Okay, so let me give one question for your homework. So question is, two uncharged metal spheres A and B are in contact as shown in the diagram. A negatively charged rod is brought near to A, but not touching it. The spheres are separated slightly and the rod is then withdrawn. As a result of this, option A, option B, option C, and option D.
When you strive for excellence, you can't settle for mediocrity. So to succeed in any competitive exams, you need to have an expert mentor, best designed syllabus, test materials, and someone who cares for your career just like you. Welcome to Regis, where our programs are designed and executed by the IITians. Enroll your board now because we believe in nothing but the best.